Now the next question is question 8. If x is equal to a cos cube theta and y is equal to b sin cube theta, then show that a dy by dx plus b tan theta is equal to 0. Now this is actually a question of parametric functions. Again, the same thing which is already discussed in exercise 2.4, but there we have used in algebraic form, but in this exercise we have trigonometric functions. So x is equal to a cos cube theta and y is equal to b sin cube theta. Then we have to form dy by dx. But you can see x is the function of theta, so we have to calculate dx by d theta because this one is a dependent variable on theta. From here we will calculate dx by d theta, and from here we will calculate dy by d theta, and then joining these two derivatives by using chain rule, we will form our dy by dx and then try to prove this result. Now given x is equal to a cos cube theta, differentiate with respect to theta, as this is actually variable involved on right hand side is theta, so just to differentiate with respect to theta. Dx by d theta on left hand side, and on right hand side this a will be constant term. Now we will use power rule here, 3 cos 3 minus 1, which is 2, and then derivative will apply on cos of theta, which will become minus sin theta. Again 3 cos 3 minus 1, 3 cos square theta, and then derivative will apply on this inner function cos of theta, and derivative of cos theta is minus sin theta. So we have minus 3a sin theta into cos square theta. And on next, y is equal to b sin cube theta. Again a given thing, y is equal to b sin cube theta. Now y is also a function of theta. We have to calculate differentiate with respect to theta. So dy by d theta is equal to 3 into b. B is the constant term, will remain same. Using power rule, 3 sin 3 minus 1, which is 2, and then derivative of sin theta, which is actually cos of theta. So dy by d theta is 3b sin square theta cos of theta. We have two derivatives, dy by d theta and dx by d theta. By using chain rule, dy by dx, as we have to form this dy by dx. So dy by dx is equal to dy by d theta into d theta by dx. Dy by d theta is 3b sin square theta into cos of theta, which is this one, and d theta by dx, we have here dx by d theta. So just to take a reciprocal of this function, minus 1 over 3a sin theta into cos square theta. Now by simplifying, this 3 will be cancelled out, sin theta will be cancelled out, cos of theta, we have only this minus b divided by a, and here we have sin theta, and in denominator we have cos of theta. This is actually like minus b and this sin theta divided by, and in denominator we have a, and this sin is cancelled out, we have only cos of theta. So we have dy by dx is equal to minus b over a, and sin over cos will become tan theta. This a will multiply to this dy by dx. We have a into dy by dx is equal to minus b tan theta, and then this minus b tan theta, to shift it to the left hand side, will become plus b tan theta, which is our required proved. Question number 9. Find dy by dx. Again a parametric function, x is equal to a cos t plus sin t, and y is equal to a sin t minus t cos t. So let x is equal to a cos of t plus sin of t. D differentiate with respect to t, as the variable involved on right hand side is t. So just to calculate a change with respect to t, dx by dt, and on right hand side a will be as it is, as this one is a constant term, and derivative of cos t will be minus sin t, plus, and derivative of cos t will be derivative of sin t will be cos of t, and y is equal to a sin t minus t cos of t, t into cos of t. Differentiate with respect to t, we have dy by dt, a will be as it is, derivative of sin t will be cos of t, minus Now when we apply differentiation of t into cos of t, we will use our product rule. So we have first t will be as it is, and derivative of cos is minus sine t. So here we have minus sine of t plus, now cos of t will be as it is, and derivative of t is 1. So this is actually differentiation of whole of this function, which is consisting of two product of two functions. So again you can see derivative of sine t is cos t, and derivative of t cos of t, this minus will be as it is. T by using our product rule, t will be as it is, derivative of cos is minus sine t, plus cos t will be as it is, and derivative of t is 1. Now simplifying this one, a cos of t minus and minus plus t sine t, and multiplying by a will become a into t sine of t, minus and plus will be minus. We have cos of t, and after multiplying a will become a cos of t. This plus minus will be cancelled out. We have dy by dt here, a into t sine of t. Again we have two derivatives, dx by dt and dy by dt. Joining these two derivatives by using our chain rule, dy by dx is equal to dy by dt into dt by dx. So putting the values, dy by dt we have a into t sine t, this one is the value of dy by dt, and putting the value of dt by dx, but we have dx by dt. So just taking a reciprocal of this one, 1 over a into minus sine t plus cos of t. So finally we have dy by dx, which is our required thing. Dy by dx is equal to, a will be cancelled out, numerator will become t sine of t, and in denominator cos of t, this minus sine of t, which is required dy by dx.